This is CSAT Sample Test 4, Question 8. In this question, we're asked to find all functions from 1, 2, 3, and so on into the same set. We could call this from the naturals to the naturals. We're asked to find the functions f of this form such that for all n, that is n is 1, 2, 3, and so on, the sum f of 1 plus f of 2 all the way up to f of n is a perfect cube less than or equal to n cubed. At first glance, this question seems very broad. There seem like there could be a lot of possibilities for our function f. And so, somewhere in the question, we expect there to be a trick, which helps us narrow down the possibilities a lot. Let's try and start working on it. Taking this long expression will be very difficult, as we're summing n different terms, and we don't know what any of them are. How could we make this easier? Are there any special cases that are easier to deal with? What about our first case, n equals 1? If we consider this case, we know that f of 1 is less than or equal to 1 cubed from this. And since we know the domain is the positive whole numbers, what does this tell us about f of 1? In fact, it tells us that it has to be exactly 1. So, for any function f satisfying this condition, f of 1 is 1. This is a good place to start. What makes sense to do next? Now, if we consider n equals 2, we already know f of 1. Our condition from before gives us that f of 1 plus f of 2 is less than 2 cubed, or 8. Does this help us work out what f of 2 is? Remember, also, that we're given that the sum is a perfect cube. That is, it's 1 of 1, 8, 27, 64, and so on, going up through the cube numbers. Combined with our inequality, we immediately see that the sum has to be 8. Why can't it be 1? Remember that f of 1 is 1, and f of 2, given it's a whole number, must be at least 1. And so, the sum is at least 2. So, given that this sum is 8, f of 1 is 1, we can say that f of 2 is 7. Can you see how this would continue into following terms? First we sum to 1, then to 8. Our numbers need to sum to a cube number, and for n is 3, it has to be at least 8, and less than 27, and so it will be 27, or 3 cubed. Intuitively, it seems like this will happen for every n. That is, the sum up to n is n cubed. But this isn't enough justification to write down in the answer to a question. How do we prove a result like this in maths? We start with n equals 1, move on to n equals 2, and so on, forever. This is a proof by induction. And so, let's lay this out formally. This is the statement we're trying to prove. How do we start a proof by induction? We start with our base case, n equals 1. And, as we already know, f of 1 is 1 cubed, which we deduced up here, since 1 cubed is 1. And so our base case is satisfied. Now, we take our induction hypothesis. We assume that it's true for some n equals k. Now, we need to show it's true for n equals k plus 1. How did we show it was true for 2 or 3? Since f of 2 was positive, it had to be at least the next cube up from 1. Yes, let's use this logic again. Since f of k plus 1 is positive, if we add it to both sides, it tells us that our sum up to k plus 1 is bigger than k cubed. How did we know that the sum had to be 8? This is because we're told that this sum on the left-hand side needs to be a perfect cube. And so it's not just bigger than k cubed, it's at least the next cube. That is, because it's a perfect cube, it has to be at least k plus 1 cubed. Now, how did we know that it was exactly 8 and not 27 or 64? Remember that in the question we're given that it's less than or equal to k plus 1 cubed. Does this let us prove our result? Since our sum on our left-hand side is at least this number, and also at most this number, we know that it needs to be exactly this number, k plus 1 cubed. And so, we complete our proof by induction. Remember what the question asked us to start with. We wanted to find the function f. We now know that this result holds. How does this let us find f? Is there more than one possibility? In fact, we can work out f of 1 and then f of 2 and so on, and each time there's only one possible value, and so there's only one possible function f. How can we write down f of n? Knowing only the sums, like this. You might notice if we take the sum up to n, and subtract the sum up to n minus 1, this leaves us with just the sum up to n, like this, since all of our previous terms cancel, leaving only f of n. And so, since we know what these two expressions are, we can write that f of n is n cubed from this bracket minus n minus 1 cubed from this bracket. And this is our only function satisfying the conditions. And so that's the end of this question.